Okay. Uh, can anyone recall what was the last point we left? The point where which we left our lecture last time? Can you recall what was the last point where we left? What was that bit? Like where at what point we, yeah, I think we were learning curves. We were looking at what are those, how they execute. So if I'm not wrong, I left at a point where I was showing you the plot, right? If I'm not wrong, I was showing you this collab notebooks. We have discussed this program. I mean, Google Colab notebook assign. What the point where we stopped was, I think we did go through this. Like, what does this graph indicate? The second one and third one. What does it indicate? So we did go through this, and if I'm not wrong, I also shared links to this Python notebooks. I think I have posted them on my GitHub repository, and I've shared those GitHub repository. I'm not sure if someone has tried to experiment. As I said, I asked you to experiment with this code samples and have some doubts so that we can discuss in our lecture or either in practical sessions. So I hope you understood this notebook file, what we did in this. For a quick revision, what we did here was we tried to model a small machine learning model which tries to fit a regression model over a set of data point samples, and we wanted to simulate the process of underfitting, overfitting, and the process of exactly getting the right value. So, as a quick recap of what we learned earlier, and what I would like to do is I would like to ask you very few small questions. So, let me see if you can answer that. Okay. So, see, my questions will be given to you in form of poll questions. Let me see how many of you can get this answer right. See, one thing, whenever I ask a question, don't think like whether it is right or wrong in that. I don't give any, for me, marks are secondary. The first is knowledge. Okay. So make sure that you recall whatever I have taught and answer these questions. So let me type the question. I'm typing the question. Okay. Okay. I hope you got the results. Can you respond to the poll? Do you see poll? You have received the poll? Okay. So now I get one vote. Can I get response from everyone? What's the issue? Like, aren't you seeing the poll, or what's the issue? You can respond me in chat. Like, okay, so are you using Meet app, or are you using? I mean, are you using Meet app or something else? Okay, so you should get some response here. In call message, I think I have seen only one student responding to the poll. Mm, okay, okay. Let me see it again once again. Let me see if I can share the question. Just okay. I think if you are using Meet app, I don't think you are in a position to get the poll information here. So if I join through, okay, fine. Okay. So I think we will discuss about something else. So what? Yeah, I think it is only visible on desktop app. Okay. The question I wanted was this. Okay, you can just type in chat window. I think this is more comfortable than using any fancy features. The question I wanted to ask is more the features to learn means more the features to learn means more the complexity of ML model. So is it true or false? So my question is more the features to learn means more the complexity of ML model. So what would be your answer to this? True or false? Yeah, the answer is true, right? So the next subsequent question follows. See what we are looking at. We are looking at you. We are trying to learn from based on this whatever we have learned on that. I'm just quickly trying to recap. So the next question follows: is more the model's complexity, more the model's complexity, more the tendency. What would be the answer for this question? More the model's complexity, more the tendency to overfit. True or false? So if you look at this, I think this plot should give you this answer. On that day, we studied what is this D, and how does this D affect. Mm. Okay. Can you respond for the? See, as discussed, more the model's complexity, more the tendency to overfit. Answer is true. Yes, as and when model tends to become more and more complex, the likelihood of model to overfit is very high. So that's what we always try to balance out uh, from number of features to learn and the model complexity. Okay. So what we left on that day was to learn this program where we left in between and where I wanted to talk you something about cross validation and what exactly we mean by cross validation. Let me explain you what I mean by cross validation. So by now, see, I think by now you know what is for example, by now you know what is training, validation, and testing, right? This you already know what we mean by training, validation, and testing. Now, assume that I have a data set. Assume that this entirely is a data set. Okay, so the entire box which right now you see is the data set. So this entirely is a data set. Let me fill it with. Okay. So whatever you see, the entire illustrative, let us consider this as a data set. And if you look at this data set is now you want to train your ML model on this, right? So now when I want to train an ML model on this, the ML model will always read data from this, right? So what ML model does, it has to read data from this data set into this ML model, and this ML model will now do a predictions, right? What we do is it now does the prediction. So let us suppose this is the predictions and this is your ML model. Okay. So the question arises, how does this ML model train on this data set? So generally, usually it is a practice that this training set is split into something called as train data set and test data set. So under training, we have this further split of train and validation. So right now, what we will do is we will not talk about validation. What we will do is we will only talk about data which is used for training and data which is used for testing the trained model. Let us only call about trained data set and test data set. So my data set would be split in a way so that a part of that split I'll use for training and a part of that I'll use it for testing. So what is your general feeling that you want to learn from a data sample? Usually how you have to split the data so that you will ensure that your learning is far more better. Can you guess any indicative figure? How should a data set be split? In should it be split 50-50? Should it be split 80-20? Should it be split 70-60? Is there any figure, or what would be the one which you would figure? So if I say I have three options. One, I want to split this data into 50-50. Second, one into 70 and 30, and third into something called as 90 and 10. If I give you this option to split this data set into a part of this data set for training and part of that into for testing, what would you prefer from the given options 1, 2, and 3? Okay. Some are saying 1 and some are saying 2. Okay. So remember, now if you're looking for something called as, I want a right answer for this. Remember, for this there is no such thing called as right answer, because how we split the data and what would be the effect of splitting the data on ML model, it it affects your ML model's training capability, and it also depends upon what you're trying to predict, what under what domain you are trying to predict, what features this data set includes. But as a rule of thumb, remember, always the training data is slightly more in magnitude as compared to the split size for testing. So we do not go for 50-50, and neither we do train on 90 and 10%. So we want to have a balance, and based on most of machine learning engineers experience and most of what people do with ML data split, the best split most people think is 70-30, or some people also think of it as 80-20 as well. So slightly it is like splitting the data set into three parts, using two-thirds part for training and using one-thirds for training. Usually this is something which works best for most of models, right? So now that you are splitting the data into this, then you what you will do is, for example, so once you split this data into the train set and then you split into test set, what you do is this train set data you will train on this, you will get a predictions, and once you get a ML model, what you do is now you give this test as an input to your prediction model. Whatever output it generates, that block, these two blocks are compared, and whatever the difference you get, that determines the accuracy of the ML model. That's how it works, right? So in this process, what do we mean by cross validation? See, when I say cross validation, see, generally when you think that when ML model trains, you think that it only trains on trained data set and it gets it, right? It's not that way. Generally, a machine learning model might train multiple times on the training data set. It depends upon what kind of ML tool, ML framework you use. But usually it is important that you make sure you properly explore the entire training set before you arrive for uh, before you arrive for actual number of predictions. So in machine learning we use a term called as epoch. Epoch is nothing but it indicates the number of passes the entire training data set machine learning has completed, right? For example, when I say epoch, this is what I call it as. We call it as epoch, right? What does epoch 1 means? Epoch 1 means the trained data set which you have here, my algorithm has gone through this training data set once. If I say my number of epochs is 2, it means that your ML model during training, it has gone through this training data set twice. That's called as number of epochs. And if I say it has epoch is 3, what does it mean? That your ML model during training, it has gone through this training data once, twice, and thrice. That's called as epoch. So don't think that once you've gone through training data you will get a model. So a machine learning model has to go through various iterations on the training data set, and then it comes to a proper ML model which with a fairly acceptable accuracy value is output from that ML model, right? So if you're thinking that whatever the training which you have done and testing which you have done is enough for ML model, it is not. So what we do is, okay, so instead of splitting the data into 70-30 and using first 70% for training, and remember that we have a concept called as cross validation. What we call it as cross validation. Now inside this cross validation, a famous is k-fold cross validation. What we call it is k-fold cross validation. Now, when I say k-fold cross validation, what does this k indicate? Here, if I say k is equal to 10. So when I say k is equal to 10, remember this data set has been actually split into 10 parts. Look at this. For example, this is part 1, this is part 2, part 3, 4, 7, 8, 9, and 10. So this data set has been split into 10 parts. Now this is called as 10. Here the k indicates number of folds or the splits in this data set. And now when I say 10, it means that my entire data set is split into 10 folds. Now when I say my train to test split, let me increase the font. So now when I say my train to test split is 70 is to 30, it means that earlier I used to say 70% of data is for 30%. Now it means that 7 parts of data is used for training and 30% remaining parts. It means that 3 parts. You can say it's 7 is to 3 is also. So this first 7 parts, will be used for training and remaining these 3 parts will be used for testing, right? Now you understood what is the meaning of this k-fold, and you also understood what is the meaning of this 70 is to 30 data split, right? Now let us understand the meaning of word called as cross validation. So this cross validation means, remember as I said, we always have number of epochs. We do not come to a model conclusion by just going through once. What we do now here, if I say epochs, number of epochs is equal to 10. Now, when I say number of epochs is equal to 10, it means that my training algorithm has to scan the data 10 times. And specifically, I would say training data 10 times. That's the meaning. So, epoch is equal to 10 means that's the meaning. It has to scan the training data 10 times. Now, when you say 10 times, you can now say, when I use word cross validation here, what it says is, so cross validation. It means that during epoch 1, let us suppose during epoch 1, it uses part 1 to 7 for training, and part 8 to 10 for testing, right? During epoch 2, what it does is it uses part 2 to 8 for training. It uses from part 2 to 8, and for testing it will use, can you guess for what part it will use? It will use 9, 10, 9th part, 10th part, and 1 for testing. So epoch 3 means what it does, from 3 to 9, and for testing it uses part 10, part 1, and part 2. So on, it repeats, and it will reach to a epoch number 10. So when it uses to the epoch number 10, how does it train? So you can see this, like it is like cyclically rotating that. So it reaches to that part 10, then it predicts the final ML model. I hope you're getting that, right? So during this process, for each of this training epoch cycle 1, you always have some metric. What was the accuracy at this point? What was the accuracy during cycle number 2? What was the accuracy at cycle number 3? So you keep on getting this accuracy for cycle 1, accuracy for cycle 2, accuracy for cycle 3. So on, you get accuracy for 10, right? So this is called as cross validation. Now, let me tell you What is advantage of cross validation? If I do not use cross validation, if I use cross validation, if I do not use cross validation, remember how you are splitting the data. You are splitting the data into 70% and 30%, and usually for first 70% you are only taking the first 70%. Assume that you are only taking for first 70% and you are missing out. What if the pattern you want to learn is inside these three parts? So your ML model will never go through that actual pattern which is present in the data. So you will always skip that data. So if you have wrongly chosen the split, it could be a case that you will miss out some valuable information your ML model might miss out. But during cross validation, what it ensures that the cross validation ensures that each and every sample in the data set will be going through training and testing process. So it ensures that your ML model has fairly gone through entire data set. It has not missed out any features somewhere in this data sample, and it has completely made use of entire data set, and whatever it learns will be comprehensive, and it would be something which it made its best possible attempt to learn from the data. So that's called as cross validation. And in machine learning, whenever I say you are doing testing training, it is almost 99%, it is always cross validation with k-fold cross validation, right? We always use k-fold validation and k value is decided. Now you can think that if k value is 10, what is the effect? If k value is 1000, what is the effect? If k value is 1, what is the effect? It is different aspect, and we will discuss that in some next lecture, right? So someone you note down and just remind me that we have to discuss effect of k on training and model accuracy, ML model accuracy. The choice of k also affects. Understood this? Have you understood what is cross validation? So can you quickly respond in chat window? Have you understood this cross validation concept of cross validation? K-fold cross validation. Others? See, if someone didn't understand, you are absolutely free to ask, because these concepts are very important, and I would be very happy to clear a doubt if someone did not, because I don't want you to keep and accumulate the doubts. Okay, if you have any doubt, get it cleared there and then. Okay, I hope you understood the cross validation. Okay, so now we have only seen partially we have seen cross validation, but here we have a lot of questions like what will be the effect of clay on training, and should we use cross validation or not. There are some samples where we should not use cross validation too. We will learn them slowly in coming lectures. So what is such problem where we should not avoid cross validation? And now you might ask me, some student might ask you that, sir, why I am taking these samples serially? Okay, why I am taking the samples 1 to 7, 2 to 8? Why not, sir? I think some students should have asked this question to me, sir, if I am dividing this part into 10 parts, why I am not taking random samples? For example, I could use part 1, I can use part 3, I can use part 5, part 6, part 8 and 9, and remaining parts for testing. This is valid choice. Do you agree that I can still use this? I can still use this, right? So instead of sequentially taking part 1 to this, I can do this way. Yes. So the question arises, what is difference? What will be the effect on machine learning model if I choose this part sequentially? And what if I, instead of choosing them sequentially, I randomly take some 7 parts? So from this 10 parts, I will randomly choose some 7 parts. It could be in any order. Like my training sample might initially go through the data present in part 8, then it might go to from 4, then it might come to 10, then it might go to 2. It can randomly go for that. So the second point what I want you to note down and remember me is effect of k, and the second one is something I call it as sampling the data set. What I call sampling the data set for training and testing data. This is very important and affects a lot the performance of machine learning model. So those all who think that machine learning model is nothing but you get a data set, apply algorithm, you will get a predictions, you will write Python code, ML is done. No, that is not machine learning. The machine learning is where a learned machine learning engineer does all this. He carefully chooses this k value. He carefully decides what samples will go training and what will go for testing. He carefully decides the machine learning algorithm, or he carefully decides whether it would be supervised or unsupervised. He will carefully decide what should be the accuracy measure, right? As of now, if you recall our earlier lectures, how do you measure accuracy of ML models? The accuracy of ML models as of now, we were talking about like this is the actual sample and I get a predicted sample, some 3 parts predicted sample. I am comparing this, whatever is error, I am calling it as accuracy. This is the most basic kind of accuracy, but remember in real world, not many ML models use this kind of testing the sample. There are a lot of other ways of testing the performance of ML model. One such is something called as confusion matrix. We call it as confusion matrix. Okay, we will see them in coming subsequent lectures. But understand that ML is not just taking data, applying algorithm, predicting. Your 80% of your ML decisions are based on what you do for this. Algorithm is already written. Remember, people have written these algorithms. You have linear regression, classification, SVM. Everyone has implemented algorithms. And then what you are doing? You have to develop the skill in using these concepts and understanding them. That is what which makes you a good machine learning engineer, and it differentiates you from a programmer and a machine learning engineer. I hope you are getting the context. Okay. So now coming back to our program, this linear regression and that, if you recall here, I am using exact same linear regression code for bias and variance, right? The same sample 0, test size and error, same this one. So I have already generated. So from the entire samples, from the samples which I have generated of 200 samples, I am using I'm using test split. Can you guess what is test size? So in what ratio I am splitting them? Can you quickly type in chat window? What is the ratio I am splitting the data here? 60/40. Yes, you are right. The split I am doing is 60/40 because I am using zero point 0.4 as a test size. Means out of 200, 0.4 means 40%. So it's a 60/40 split. Then I'm generating the samples. I have X train, Y train, and I'm generating all this. Then I'm just plotting them here. So when I do this plot, it's a matplotlib. It is pointing. So red dots are training samples and blue are test validation. What they are? They are the points which I use it to test my regression curve, right? So this, when this is your training and test data set, and when you execute this further model, what you get is, see, same I'm doing. What I'm doing, I'm using degrees. And how many degrees I'm using? From 1 to 21. I am testing it for 1. If you look at here, um, for each range I am taking it and then I am plotting it for every degree value. So here I am generating training scores and validation scores. Now let me tell you what I am talking about. When you execute this, I am plotting it for degree of fit. So what I am saying, I am running these features for when I want a polynomial degree to be 2.5, 5 to 10 to 21. So I'm increasing the polynomial degree fit, right? And I'm checking how this these curves are plotted. So here this is some metric, this is, let us suppose this is a metric which indicates the performance, the of your ML model. So what I'm doing is, so when you put the validation curve, it means that during training whatever you are learning, is it matching with what you are doing it in a cross validation? So you're training and validating, training and validating, training and validating. The training and validating is matching as long as your number of degree fits is within 2. You can see as and when you are increasing the model complexity, I hope you see this, as and when you are increasing the number of features to learn, it is increasing the model frequency. As and when you are increasing model frequency, the difference between the training, what you are learning in training, and what you are getting in while cross validating it, when you are validating it, the difference is growing on. This is always growing on. It means that what you are training is not matching when you are trying to validate. So this, it is increasing the variance, it is increasing the variance, you see here it is increasing the variance and it is deviating too high. So what it is indicating, that during training as and when you are increasing, it is trying to overfit. Since it is overfitting, you are getting very vague results and it is not matching when you are validating the results. So as and when you see here, it always validates, the difference is too high. Are you getting what this graph is trying to plot? Now, when I come back to learning curves are something, what we do is we plot it for very basic degree. Now, see, I have plotted it for entire term, but now what I am doing, I am detailing out here. So what I am doing, I am only choosing 3 degrees for degree 1, degree 5 and degree 15. Here I have generated it for degree 2 to 21. But now what I am doing, I am generating what will be the curve when I use it for degree 1, what will be curve when I use it for degree 5 and what will be curve when I use it for degree 15, right? So the same program, see, we will work on this program some other day. I'll explain you each and every line, what exactly it works. Probably in practical, I'll explain you what exactly detail what it is. So I'm just assuming that you're good in Python, and I'm just assuming that. Let me know if you want me to explain you each and every bit of this code. We will do it in some another lecture. So here, what I'm doing, for each degree, I'm repeating this pipeline. I'm trying to print them. Now, when I'm trying to print them, when degree is equal to 1, what do I see? As I said, this validation and cross validation, they have to converge. They have to converge at point. So when you train it on 20 samples, see how many samples I have? 200 samples. But what I'm doing, I am checking this. What is the training accuracy and cross validation when I train on 20 samples? What is accuracy? What is this variance when I'm training on 40 samples? What is when I'm training on 60 samples? What is when I'm training on 80 samples? What is when I'm training on 100? What is when I'm training on 40 and 160? So when you can you guess why it ended with 60? Because we are maximum using 60% for training. Okay. So when you say here, when I have stopped at the 60%, you can see here that there is a slight difference between these two curves. Okay, so you can see how they are working on. At the same time, when I increase the sample to 5, you can see the difference is still here and the difference is still there. So at a point it converged and this. So still if you increase points, at some point it will converge. And this is 15, you can see the difference here. So as and when you keep on increasing the more model complexity, tendency to do overfit increases. And see here, if you look at, so here if you look at here, what it is indicating, the gap is higher here as compared to gap here. It means that these are converging. These are converging. So 160, with by analyzing 160 samples, it was able to almost reach to a point of convergence. But when you increase the model complexity, degree is 15, model complexity is high, and as and when you see here, see, when the model complexity is high, it is not able to learn from less training samples. If model complexity is moderate, around 5 and 1, it is able to just converge at very basic samples. So more the complex model, it requires more data. So here what you can see is, probably it is indicating it is still, it has to converge. 160 samples are not enough for this model to learn properly. So more the complex model, You give a less data, it will underfit. So it still requires more data. So as a machine learning engineer, when you work on these training samples, when you look at these graphs, you get an idea that am I going right in the training sample? Is the training 10 test split fine or not? So now this train and test split was for uh, it was for 60 and this one. What if I do this as 1? If I do this for 1, let us see what type of graph we get. Let me. I think I have to execute all these models one by one. Two. So here I have done almost 90% training and 10% for test. So you can see that obviously the number of blue samples are less. I'm using far less amount of data for testing. Do you think this is recommended? Now, if you look at this figure, you will understand. See how it is. And here you should see the difference. Okay. So you can experiment with this. See, I have given you this Python notebook file. We will be using this program very often for some coming lectures to understand the difference between data and all that. Okay. So I have given you this notebook file. Go through that and try to learn. Like what I mean to say is, you can increase the number of training samples. This is how it happens. When you execute on this, you can see more training tables, perfect convergence. You see a perfect convergence. So this gives you an idea like how the data is affected. You can see when I made the samples to 20,000, there was ample amount of data to learn. I hope now you are getting a sense. What does it make sense? Like when you have high amount of data, when you train too much. Now let me make it as 40. You can see that how it works well. So you can figure out what works, what should be the data sample size, and what if sometimes we do not have a proper data, how it affects, what are number of features. As I said in this diagram, what I was saying is, as I was saying, what happens on this is, this matters a lot. Okay, so you have any questions? You have any questions? You understood? Okay, I think this lecture I have recorded. I'll upload it on YouTube. See what I want. I want you to go through those recorded lectures, and any doubt which you feel, don't worry. It could be very stupid questions. Fine, you ask me. Remember, I'm telling you. Sometimes even I might do a mistake. I want you to go through that. So this area is so broad. Machine learning is never-ending process. So go through that. Any small silly questions, good question, fine questions. Don't worry about that. You have a doubt, get it cleared. These initial lectures are very important. If this foundation is good, you do not need a teacher anymore. You can do your own machine learning. You can experiment with any complex model. I hope you are getting that. Okay, so I'll just end this lecture here. Mark your attendance, and you should be fine to leave.